Okay, so it's time to look for some rather advanced ways of indexing things and starting to look at how we might do that vectorization of code we talked about last time. And if you take a look here, I have my favorite file, which is grades.txt, and like before, it just contains all these made-up grades. And I'm going to run it. I'm going to make sure it's in my workspace. I type grades, and there it is. Okay. So the first thing we're going to do is try to access the last element of the array. And amazingly, MATLAB has some really fantastic stuff for doing that. So for example, in order to do that, and let's do it in the command window, I say grades at end. And end is then the last element of the array. And I see, in fact, it is 94.479. If we look at the original data, we'll see it's, in fact, exactly 94.479 right there. So it's just one way to get the last element is to say end. And now what we can do is make a new vector that, maybe as we're going to cut out the last element, for instance. So we say new grades is equal to grades from 1 to end minus 1, for example. We could do end minus 10, whatever you want. And the idea there is that it starts a vector at the first element, goes all the way to the last element except for 1, so it's the second to last element, and in steps of 1. So this is a fast way of doing a vector whose steps are 1. And if you want to see what that looks like here, let's actually do that. So if I say 1 to 10, for example, it's going to give me a vector that gives me all of the numbers from 1 to 10 in steps of 1. So if I run this now again, and I take a look at new grades, we're going to see that the last element is 90.272. And if you can take a look at the file here, 90.272. So it's exactly what it says from the very first element down to the last element except for 1, so the second to last element, which is 90.272. Okay, so now let's say that I wanted to subtract these two things. I can't do that on its own. So unfortunately, new grades and grades have different sizes, so I can't add one to another because it's undefined. So if I go into my command window, and I say, what is grades minus new grades, it's going to give me an error. And it says matrix dimensions must agree. So just be aware of that. I mean, what I did there was I took off the last element, and not surprisingly, something has gone wrong. Okay. Now let's do something quite cool, and I'm going to write it here in a comment first. And we're actually going to delete new grades. We don't need this. And we're going to take the difference between neighboring grades. So what I want to do is compute a vector that contains the difference between grade 1 and grade 2, the difference between grade 2 and grade 3 and grade 4, and so on. And in order to do that, MATLAB has this great functionality, which is the indexing. And I can say, diffs equals grades. Now I want to go from 1 to the end minus 1. So I don't want to have all of the grades because I can't do that. There's not the next grade after end minus 1. So I say 1 to end minus 1 minus grades from now 2 to the end. And what this is going to be is the difference in those two grades. I don't know, maybe we're comparing students who are right next to each other. And so this is one way to do that really, really fast without needing any looping whatsoever. I'm just doing it based on the indexes. And if I run it, then notice I didn't have a semicolon here. I get the differences between the grades there. Okay. The next thing I want to do is instead of getting every single grade, maybe I want every second grade or every third grade. And MATLAB is, again, really quite good. And it doesn't matter if you have an odd number, an even number, whatever it is, MATLAB will figure that out. So if I just want every second grade, I might do something. This is take every second grade starting at 1. And I say ESG, every second grade, equals to grades 1 in steps of 2 to the end. So what that's going to do is take the first grade and then the third grade, which is 1 plus 2, and then the fifth grade, 3 plus 2, and so on, and give me that. And so if I'm going to run that, then I get, in fact, what we're asking for. And just to look at that file again, so what we saw is 90.272, which is right there, and then it skipped this one and gave me 41.720. So it's every second grade, and that's why I don't have this one here, because we're starting on an odd number, which is 1, and I have an even number of grades. It's not going to give me the even numbers, basically. It's what I just told MATLAB to do. And as you can imagine, the step size doesn't really matter as long as it is less than the amount of data you have. So let's say in steps of 10, for example, and if I'm going to run that again, it's going to overwrite my variable, and we in fact now have every 10th grade, that sort of thing. So MATLAB is great for that kind of logical indexing, and it allows you to really do some powerful stuff with your arrays that honestly is up to you in terms of what you're going to do. But it does allow you to avoid using for loops as much as you can, which is a really good thing because honestly MATLAB for loops are not that great. They should not be used if you can vectorize your code at all. And now just one thing to keep in mind is that vectorization is a little bit of a hard concept to wrap your head around sometimes, and so it typically takes longer to write vectorized code, but the payoff is a much faster runtime. So if you're going to be running this code over and over and over again, maybe for several years, you're analyzing big amounts of data every day, for example, vectorization is a good idea. On the other hand, if you just want to process the data once and you think like a C++ programmer and you want to use a for loop and it's not really going to take much extra time, you might as well just use a for loop to do that.